Hello everyone, I'm Crystal.
I'm Yuki.
I'm Carrie.
And today we'll be explaining this drawing for you guys. So basically this drawing is based off of a lab where we observed and created biopolymers. So in this lab we had 6 flasks of iota carrageenan, and each with different concentrations of CaCO2 ranging from 0.0% to 0.5%. These solutions were all heated to prevent them from solidifying and gelling up. So basically, the purpose of this lab was to observe the time it took for each solution to solidify. And after that, we used pennies to determine the elasticity of each gel. So from our observations, we found that the 0.5 CaCO2 concentration gel took the shortest time to solidify and was the most elastic, while the 0.0 concentration didn't gel at all. After that part, we added an enzyme to a gelatin sample, and it broke apart and became a liquid.
Okay, so here's a drawing that represents the experiment. So firstly, there's a 2 workers. They are built the railroad, and so at the first time they just built like 2 wooden borders. So when the trial goes through this railroad, it just broken and bounced off. So the next time, the workers are trying to build more wooden borders. So the next time the train is going less successfully. But like 6 months later, because it is wood, so there's a termite that eat most part of the wood. So the next time when trial goes through the road, it just bounces off again. So finally, the worker is realized that, and to replace the wood by the iron.
Okay, so
you can't adjust the mic.
so the boards in the middle of the rails, they connect the 2 rails. So the boards here, they connect the 2 rails, and they shows the calcium ions that connects the iota carrageenan we use in the lab, and they form the iota carrageenan polymer. And in the experiment, when the calcium concentration increases, the gels form quicker. The gels form quicker and stronger. So this person shows that by like when they have 2 boards in the middle of rails, the train just derails. But then when it increases the concentration of the boards here, the trains can go through it like perfectly. And this part shows when the enzyme can break down the gel polymer. So it shows by the termite eating all the boards. So it's like the enzyme. And then it also shows how the polymer is formed by exact repeats or repeats of a certain type of monomers by showing how the rails are made by the repeats of the boards. Yeah.
Okay, so our group is unclear about like the last picture. So it is that the wood is replaced by an iron. So at this point, so we just don't know why it should replace by the iron. And our guess is like the different connection in biopolymer determines strength and functionality of resulting network. And another part is we saw the student can add more concept that is heating and cooling affect biopolymer structure. So as the railroad is replaced by iron, the iron can be expanded when the weather is hot. So when it reaches a limit, it will like broke. But like when the weather is cold, so they will compress together, so which just make it stronger. Yeah, thank you.
Do you have any questions?
So I'll start off with a question, and I'll help you guys figure out the last panel. So you guys mentioned, I think you mentioned that the termites are representing what concept here?
The enzyme breaking down the.
Yeah, good. So what is it about then the enzyme that is sort of unique compared to like other ways of breaking it down?
So like the only animal that eat the wood, it's the ants. So like the human really like look seriously at the ants when like our home have ants or the termites, they'll like call police to like destroy it. Mm-hmm. So like this one is like enzyme. That's the only thing that not the only thing, but it's like the same function that will destroy the polymer.
Right. So then, if it's iron instead of wood, then would the termites be able to consume it?
So the termites will not like eat it, so it's not wood.
Exactly. So then what term do you think I would be trying to hint at if the enzymes would eat one thing but not another thing?
Oh, I realized that because like in our lab, there's like the blue gel and the transparent gel. So like the iron is like the blue gel, which enzyme cannot break it, and the wood is like the transparent gel, which the enzyme can break it to liquid.
So do you guys remember the term for that? With that, it's like enzyme
degrading.
So specificity was the thing I was trying to think of, right? So that it only breaks down a certain type of thing and not another thing. But nicely done. Any other questions? Anything that yes? Question over there.
What about the calcium ions makes them bond the two polymers together?
Oh. So the calcium ions have two positive charges, and the alpha carrageenan, it has like each has one negative charge, so it can like get the electrons and then they connect together.
So as a follow-up to that, is the charge of the calcium compared to the charge of the iota-carrageenan represented here?
In this picture, it's not that clear. But it shows like the connection and the bond, but it doesn't specifically show like the charges of like say like the rail and the wood versus the wood. So I think it could be made more clear in that way.
I think I might actually see it. So if you're looking at the rails, how many rails are there on the track?
Two.
And then how many blocks of wood would it take to just even make any connection between the two? Just one. It would just take one block of wood to connect them, right?
Yeah.
So then what charge ratio do you think could be represented then?
2 to 1 ratio.
+2, right? So if each calcium has a +2 charge, each block of wood can bring 2 of those rails or 2 iota-carrageenans together. So that is how I think that this artist meant to represent it. Any other questions? Yes, one more question.
Oh, I just want who's the artist on this project?
That's a great question. Would the artist behind this please stand up?
Yeah.